Welcome back, everybody. This is going to be the final of 5 parts in my lecture series on functions. If you haven't seen the first 4, please go and watch those now. In this video, we're going to talk about piecewise-defined functions. Let's get started. A piecewise-defined function is just some function where the defining rule changes partway through the domain. And we represent them with these big curly braces like you see in the first example below. Here I have a piecewise defined function, and this tells me what to do with the input still, but it depends on what the input looks like. If the input happens to be negative or less than 0, I do this with it. If it's positive or greater than or equal to 0, I do this with it. So let's take a look at how we would use this to find f of negative 2, f of 0, and f of 3. Well, when I try to find f of negative 2, I have to check what defining rule this falls under first. Negative 2 is a negative number, so it falls under the top piece of the function. So I use the top defining rule. 3 times input plus 5, which is negative 6 plus 5, or negative 1. It gets a little bit trickier when I go to f of 0, because now I have to pay close attention to the defining rule, as this is where it changes defining rules. Notice it still falls into the second camp, though, because 0 is greater than or equal to 0. So I use the bottom defining rule. 4 times input plus 7 is going to be 7. Last but not least, f of 3 is going to fall under the second camp because 3 is greater than or equal to 0. So I take 4 times input plus 7. Which is going to be 12 plus 7, or 19. So, what do these things look like? Let's try and sketch the graph of g of x equals negative x if x is less than or equal to 0, or 4 if x is greater than or equal to 0. And it might be helpful to sketch a little table of values. I like to put at least 3 points per piece into my table, including the place where they switch up. So they're switching up at 0. So let's find 3 numbers to the left of 0, like negative 3, negative 2, negative 1. Let's see what happens at 0. And then let's see what happens at 3 numbers to the right of 0. 1, 2, and 3. When I plug in negative 3, I'm in the top defining rule. So I use this guy. And I take the opposite of the input and get back 3. Pause the video here to see if you can finish filling out the table. We should have 3, 2, 1, 0, 4, 4, 4. All 1, 2, and 3 are equal to 4 because it tells me if the input is positive, the output is just the number 4. So how do we graph this? Well, for starters, we need a coordinate axis. Now let's plot all of those points. Go ahead and pause the video here, see if you can do it on your own. Here's what they look like. How do I connect the dots? Well, I certainly know to the left of 0, it's going to keep continuing this pattern. And to the right of 0, it's going to keep continuing this pattern. But at 0, I don't have this point. So I fill it in with a hole. In this video, we learned how to evaluate and graph piecewise-defined functions. And this is going to wrap it up for my lecture series on functions. Catch y'all in the next one.